Today is 8/10, November, 3rd of November 2024. We will do a game, look up the set theory and analysis in quick 10 or 15 minutes. In this series, we will talk about relations, equivalence classes, and partitions. First, when there is the Cartesian product of two sets A and B, we will say a binary relation. For subset R or Cartesian product A and B, from this binary relation, there's something very special that we will call it function. And if in particularly function, there is very important concept which is one-to-one and one-to, which is called as surjectivity and injectivity. One-to-one is which is when element in domain shoot into codomain, and when the element hit in codomain is recorded as range, and on2 is range is getting bigger and bigger, and so range becomes same with codomain. We will call the condition as on2, and we can represent on2 as a complement set of range and codomain equals to 0. Intersection of complement of range and codomain equals to 0, then we will call it on2. And one-to-one is condition that when x1 and x2 is different, then fx1 and fx2 should be different. This is one-to-one, and in particularly for linear combination, in particularly for linear transformation mapping, we can think of it as linear transformation, as we studied in linear algebra. Then in that case, on2 will be corresponds to consistency of metrics, and one-to-one will be corresponds to linear independentness of each columns. So it was the explanation of relation. And from relation, there is equivalence relation, which satisfies the following three conditions, which is first is reflexivity, which is A, is also in relation R, and symmetry, which is if there's A, B is in relation R, then B, A is also in relation R. And third one is transitivity, which is if A and B is in relation R, and if B and C is relation in R, then if there is relation in A and A, C is also in relation in R, then we will record it equivalence relation. And bijection is which satisfies both surjectivity and injectivity. So let A be a set and 2A be its power set. Define a relation R on 2A as follows. 2 to the A follows. When X and Y has relation, then some function Y to the X such that F is bijective. In other words, relation X, Y, which is element of 2 to the A, Cartesian product of 2 to the A, something bijection F, which then element of Y to the X, then R is an equivalence relation on 2 to the A. So we can also define indexed family. We can define image of A as with indexed family of element. We also discussed about partition. Partition is thing that satisfies these three elements. First is non-empty subset. Each subset A is non-empty. And pairwise disjoint, which is uh, some subset of AI and some subset of AJ are disjoint, and third one is union covers the entire set. So if the union of all subsets should cover all the area. Equivalence class is based on define the equivalence relation. Then we will see the equivalence class of X, which is element of S under R is the set of equivalence relation of X, equivalence class of X, which is under relationship, under relation. Let R be an equivalence relation on set S for any X, Y, which is element of X. Let X and Y represent the equivalence classes of X and Y respectively under relation R. Then there is lemma. All X is element of equivalence relation on a set S. Then X is element of equivalence relation. If X and Y have relation, then equivalence class of X and equivalence class of Y is same. And if X and Y doesn't have relation, then equivalence intersection of equivalence X and Y has zero element. Based on this, we can talk about fundamental theorem of equivalence relation. Let S be on set and let L be an equivalence relation on S. Then we can define the set of equivalence classes as equivalence class of R, where the Y is element of S and X and R, Y has relation. Then P performs the partition of S. So it is kind of link between equivalence class, equivalence relation, and partition. So we can more rigorously define it with theorem 6 relation induced by partition is equivalence. Let S be a set and let P be a partition of X. Then we define relation R on S, which will be some I is such that XY is in the element of PI. Then we can also define relation based on partition. And we will quickly go to analysis. Let in first part there comes intermediate value theorem. Let A be the interval of A and B is and be a real interval. Then there will be continuous function, and let's say FA is smaller than FB. Then there is some R which satisfies FC equals to gamma. Jonathan yesterday gives us very interesting example, which was let's say if there is Jonathan made a circle here, and circle is kind of temperature in, let's think about Korean Peninsula here. I will make Korean Peninsula. Yeah, yeah, there is Korean Peninsula. We can think of a circle which represent some temperature. Then in this circle, this is continuous function. So if we select A and B, F and B, then there's some gamma which becomes some which will be smaller than FB, FA and bigger than FB, smaller than FB and bigger than FA, which means there is some specific area which satisfies some specific temperature. This is what very interesting thing we can suggest. We can intuitively know by intermediate theorem. So let's go. Let S be an non-empty subset of R. Then we will say S is bounded above if some B, which is subset of real number, X satisfies beta is bigger or same than X. We can easily say there is some real number B which satisfies this, then we call it upper bound. And in the same way, there is some A which is smaller than or X, then we will say it is lower bound. And a set is bounded if it is bounded above and not below. And we can show that A or minus 1 over n has an upper bound and lower bound. We can say A goes like this. Then 1 minus 1 over n is smaller than 1. So thus for all x, we have x smaller than 1, so x has bounded above. And like similarly, we can show it is bounded, we have lower bound because we have n is bigger than 1, so it is smaller than 1, so it is always bigger or same than 0, so it has lower bound. And we can also show R such as bigger than 0 and R squared is smaller than 2, we can show that it has a lower bound of 0. And we can define supremum and infimum by which is least upper bound and greatest lower bound. If we see supremum, then it is beta will be upper bound if the first one is definition of upper bound, and second one is from any upper bound, if it is smallest one, we will call B as supremum. And we will also speak about, we also show about uniqueness of supremum and infimum. Okay, next time then we will go to well-ordering principle and mathematical induction, and also Archimedean principle, which is a property of real numbers. And we will also talk about axioms of real numbers and field axioms, so on, in next time. Is there any questions?
Could you explain what a power set is?
Power set. Nice question. Wait a minute.
I do remember the term from analysis class, but I don't recall exactly how they worked.
I will, wait a minute. I will use whiteboard. Let's say set has a comma b comma c, element a comma b comma c. Then the definition of power set is a set. Oh, wait a minute. What was the definition? Oh, yeah. Set of all subset of S. So if we think about the subset of this, then it will be A. It is subset of A. This, let's say this is S. If we think about subset of S, then A will be subset of S, and B will be subset of S, C will be subset of S, and A comma B will be subset of S. A comma C will be subset of S, and power set is dot dot dot. There will be more. Power set is all the power set is set which element is all the subset or
Contains all the subsets.
yeah, contains all the subset. That is the definition of power set. So usually we can see basic mathematical we can see in mathematics class we need to calculate sometimes how many elements the power set has. Then we usually use 2 to the 3 minus 1, which is 2 to the 3 is all the combination of this element, which means it will be the subset. But in case we have also the number of case, we didn't select A, comma B, comma C, then it will be subset of it will be empty subset. So we will remove it. And so there will be, in this case, there will be 7 number of cases of subset can be exist. So we can say power set has 7 elements.
Okay.
Okay.
That answers my question.
Okay. Oh, thank you for great question. Based on this question, power set is very important concept, and power set is actually related with bit string in computer science. For today, I don't know much about bit string, so if I have next time, if there's opportunity, I will also talk. I will also introduce about bit string and the relationship of power set. Okay, is there any other questions?
No, for me it's fine.
Okay, then thank you for participate today.